as promised, here is some stuff with completing the square, and I decided to take it one step extra and show you how to put it in the form of how you graph your parabola. So if you guys want to follow along with me, you can. I'm going to post this Word document on the website as well as my answered stuff that I've done, and so at the end of this you can see those are your problems that you're going to have to work. So if you want to just get the problems, here you go. You don't have to watch the rest of the video. If you want to watch the rest of the video, stay tuned. Alright, so if you want to look at your book while we're doing this, if you're not sure what page, I don't have it up. It's right here. Nope, not chapter 6. Chapter 7. 423. Here it is in your book. It's page 423. So if you want to go there, you can. But I am going to continue on. So if you have any questions, just stop it, rewind it. If it's still confusing, just shoot me an email. Alright, so the very first thing that we see is that we have two forms. It opens it either vertically or horizontally. The x is in the squared if it's vertically, the y is in the square if it's horizontally. And what you're going to find is these two work the exact same way, and I'm going to work one of them out so that you can see that. The only difference is your focus. You kind of change those up a little bit, and your x equals, your y equals, that stuff changes, but everything else stays the same. Alright, so the first one, we have a squared plus 2a minus 3 equals 0. I'm going to go ahead and change that to x and y. So we have x squared plus 2x minus 3 equals y. So we want to go ahead and get that in our format so we can complete the squares. So we have x squared plus 2x plus something equals y plus 3 plus something. These two have to be the same thing. We take this 2 and we split it in half and we square it. So this is just going to be 1, and 1 squared is just 1. So 1 and 1. This becomes x plus 1 squared equals y plus 4. Now, the reason we know that this is x plus 1 squared is this is a perfect square. And we know that because if we look at the factors that multiply together to get 1 and add together to get 2, that's going to be 1 right here. And we found that from this middle thing that we found when we halved it before we squared it. So we know that that's what it's going to be down here. Hopefully you'll get enough practice here that you'll see this connection, how you know this is the right one, but all you really need to know is the sign stays the same here, and this just comes from whatever number we found after we halved it. Alright, so now we need to get it into this form. The x minus h squared equals 4p times y minus k. So we have x minus negative 1, so we have that x minus some h value, equals 4 times 1/4 times y minus negative 4. Now, all I did here was I just got it into a format so we can easily see, okay, this is h, this is p, and this is k. So we know that h is going to equal negative 1, just right there. K is going to equal negative 4 right there. Now p is going to be the hardest one that you're going to have to find, but this 4 is going to be there no matter what. You're going to have to figure out what p value you have to put here in order to get whatever coefficients on the outside of this. We're going to do a couple here in a little bit where you actually have a coefficient out front, so you have to do a little bit more math. But right now we just have 1, so we have to figure out what fraction can go here that cancels this 4 out and just leaves us with 1. Well, that's just going to be 1/4. Alright, so now all we have to do is plug everything else in. So if you look here, our orientation will be that it opens vertically. Our vertex is going to be HK, so it's just -1, -4. Our focus is going to be -1, and then we have -4 plus 1/4, so that's going to be, that's the same as -16/4, so we just have -15/4. Then our axis of symmetry will just be x equals -1. That just shows where it reflects. And then our last thing, our directrix, is going to be y equals, now it's k minus p, so it's going to be -17/4. Alright, so easy enough. Now we can check to make sure this is completely correct by going to our graph, saying y equals x squared plus 2x minus 3. We graph that. I'm going to zoom just to get that standard. This is what yours should look like. So the first thing, we can see that it opens vertically. Next, our vertex, it says it's at -1, -4. That looks right, but maybe we still want to figure it out for sure. So what I did was I just went to second trace, and we can go down to minimum. We can do our left bound. So see how it has left bound, then it had right bound. So we scoot over, just like when we were finding our min and our max before. And then it approximates it, so this is approximately -1, basically -1, -4. So we know that's right. Then our focus is just going to be slightly above that. And then we have our axis of symmetry. The rest of the stuff you can kind of see, it follows the same pattern as what the other ones do. Alright, so this next one, I want you to pause this and I want you to try it on your own. I'm going to wait just a second and I'm going to continue doing this one, so if you have no idea what's going on, you don't have to pause it and I'll just keep going. Okay, so hopefully you figured this one out, but if not, I'm going to work it out. So again, I like converting it to x and y. I don't like the different variables. So if we have x squared minus 2x plus something equals y plus 8 plus something else. So notice I just moved this one over there. Alright, so if we have 2 divided by 2 squared, that's just going to give us 1 squared is 1. So then we have x, the minus stays, and then whatever this was goes here, so we're going to have 1 squared equals y plus 9. Okay, so the next thing we do is we can get it in our form over here. So we have x minus 1 squared equals 4 times 1/4. Notice, because this coefficient is just 1, that's always going to be true if you ever have 1 as a coefficient. It's always going to be 1/4 here. Then you'll have y minus -9. Now, you don't have to put the y minus a negative. If you see a plus, you just, can assume it's negative, then that's fine. So we know h equals 1 this time, k equals -9, and p equals 1/4. Alright, so our orientation, again, is going to be that it opens vertically. Our vertex is just going to be hk, so 1, -9. Our focus is 1. Then -9 plus 1/4, so that's going to give us -35/4. You can check my math if you want. And then we have a of s, our axis of symmetry, is just going to be x equals 1. And then our last one is just going to be y equals -37/4. Now, I'm sure the question that's pressing on your mind is, what if it opens horizontally? What has to change? Well, all that would change is this becomes y squared minus 2y plus 1 equals x plus 8 plus 1. So all I did was change each of the x's to y's and each of the y's to x's. So then we would have y minus 1 squared equals 4 times 1/4 times x plus 9. And so now our h and our k are going to be the same, and our p, so we can see that it's still going to be, so our x and our h are still going to go together here, and our k and our y are still going to go together there. So our h is still going to be -9. Our h, oh no. That's y. So I'm going to write this up here, right here, so we can refer back to it. We want it in the format y minus k squared equals 4p times x minus h. So notice that we have our k with our y still. So k went with our y here, and h went with our x here. So our k will equal 1, our h will equal negative 9, and then our p will equal 1/4 still. Yeah. And so now our vertex is going to still be HK. So it's going to be HK. So now it's going to be negative 9, 1, positive 1. I was going to say negative 1, but we say K is positive 1. Then our focus is just going to be H plus P. So we have H plus P here. So that's going to be negative 35 over 4, comma, and then K. And then our axis of symmetry is just going to be y equals k, so y equals 1. And then our last thing, we're going to have x instead of y. We're going to have x equals h minus p. So that's going to give us negative 37 over 4. So notice a lot of this is very similar. We're using the same exact numbers. It's just we switch them around a little bit. So the exact same problem, except we switch the letters. So if our y is what's in here, then it's going to open horizontally. We label everything accordingly. Notice that the h and the k's still go with their y's and their x's. So k goes with y, h goes with x, just like we had here. Alright, so hopefully that helped. Now we're going to move on to these last four. The only difference with this is you have them on both sides, so we have x squared. Okay, sorry, I had a phone call. I had to stop and take that real quick. So I'm not going to be able to get through all four of these with the time I have left, so I'm going to make another video. So I'm going to sprint through this one and see if I can get to the next one. Alright, so we would have x squared plus 10x plus something equals y minus 21. I just moved the 14 over. So if we take 10 divided by 2 and square it, this becomes 5. Squared is 25 plus 25. So then we have x plus 5 squared equals y plus 4. So then we know that our h is negative 5, our k is negative 4, and our p, like before, is just 1/4. So then we know our vertex is going to be negative 5, negative 4. Our focus is going to be negative 5, negative 15 over 4. Our axis of symmetry is going to be x equals negative 5. And our last one is going to be y equals negative 17 over 5. So you guys try this one, and I will come back on the next video and show you how that one's worked. Alright?